To everyone in physics fire. Today we are going to do the fourth part of current electricity. The first three parts we learned about what basics of current, drift velocity. Then we learned about current density. We learned about Ohm's law. We had many numericals in between. And then temperature dependence equation also we had done. And we learned about resistance. Now we are going to do what combination of resistance. It's a easy topic if you'll understand properly. Let's get started. So combination of resistance, if you will see, it will be of two types. Two types are there, combination of resistance. First is what? Series and parallel. Combination of what? Resistance. Combination of resistance. So first is what? Series. If somebody is having problem to understand like how we can find series and parallel, those things also we will do. Series connection and what? Parallel connection. Let's see first series itself. So series, if you are going to see the first, I'm considering 3, more than also is possible, less than is also possible. So let's take this circuit. The resistance here is R1, here is R2, here is what? R3. Here the voltage is V, right? Now in series, how we can consider, let's consider suppose from A to B you are going somewhere. Let's understand what is series, how we'll say series. So if you are going from A to B, let's take the distance between them is 2 kilometers. 2 kilometers, right? You started from here and you ask someone that I want to go this place B, right? So how should I go? So if anyone can say you, it's an easy way. Directly what you do, that you just start from here. The end point is going to be what? B. In between, there is no signal, no stoppage, nothing. There is nothing here. So no need to worry. So you keep on going the same road without any disturbance, no confusion at all, is known as what? Series. So whenever current started from a point, right, now it is coming here, here, and then here, and finally here. So ultimately what happened? It is not having any problem to go till what? Till the voltage to come back. So we say it is in series. Series means what? Current will not face any problem, any confusion will not have in between that how should I go? Is there any change of way there in between? If there is no change of way in between, then we say what? It is in series. It is what? It is in series. Hope so you guys got it. What is series? Now let's see what is same in series. So in series, current is same. Current is same in all the resistors. In all the resistors. In all the resistors. Got it? Now what? Second is what? Voltage is different. Energy will lose. Suppose you morning you came, like it took 2 hours to go from A to B, here, and you are going by walk. So of course you will have more energy here, then less here, least here, because you are losing your energy. So voltage is different in all the resistors. All the resistors. Right? Now let's see, suppose voltage is different, then we can say, let's find the formula for that. So sometimes they ask in board exam directly that derive the series like R1 is equal to R equivalent is equal to R1 plus R2. So what we can do here, what is different? Voltage is different. So net volt is equal to VR net. Sorry, net volt is equal to what? Voltage is equal to what? IR. So IR net. What is same here? Current. So we can say I R. So ultimately, if you want to find the net voltage, total volt here. So V net is going to be V1 plus V2 plus what? V3 till infinite, right? We can say till n. So we can say IR net is equal to IR1 plus IR2 plus IR3. That will be there, right? So we can say here I is same. Why? Because current is not getting confused. So net resistance is equal to R1 plus R2 plus R3 till what? RN. That is going to be what? The equivalent resistance in series. Hope so you guys got it. Now let's see combination in parallel. R1, R2, R3, right? Now the problem here is what? It is a way in between. So you want to come from A to B. It is a 2-kilometer road. So once you'll come here, now you're getting confused that I should go in this direction or in this direction. Once you came here, I should go in this direction or in this direction. Once you came here, in this direction or this direction. So whenever current is facing a problem, like it will get confused, then we say what? It is in parallel. So easy way to determine whether it is in series or what? Parallel. So we can say till here it is I, that is correct, but here it will be different. It will be I1, here will be what? I2, here will be what? I3. What is same here? Voltage is same. Voltage is same in all resistors. Right? Next is what? Current is different. Current is different in all resistors. Understood? Let's see now how we will find current and voltage here. Current is different in all the resistors. First we'll find the formula. What is different here? Current. We know that I is equal to what? V by R net. I net if you want to find. So total current is going to be what here? I is equal to I1 plus what? I2 plus what? I3. So I net is equal to IR1 plus IR2 plus IR3. No, I is equal to what? V by R1, right? I1 is what? V by R1 plus what? V by R2 plus V by R3, right? So we can say V by R net is equal to V by R1 plus V by R2 plus what? V by R3. So V cancel out. So R net is equal to I by R1 plus I by R2 plus what? I by R3. By this way, we can find what? Voltage. Now we understood that what is current in series as well as what? Parallel. Hope so you guys understood properly. Now we are going to do few sums of that. Let's see now. Just cooperate me first few questions, then it will be easy for you guys for series and parallel question. Let's consider this is 3 ohm and this is 2 ohm. This is 4 ohm and this is what, 3 ohm. This is 10 volt. The first question they are asking here, find R equivalent. Second question is what, current through battery through what, battery. Next question is what, current and voltage, current and voltage in 4 and 3 ohm. Let's see current and voltage in 4 ohm. One you will understand, then it will be easy. Let's see the first question, R equivalent. Guys, these two are in what? For sure, current once will come here. It will not get confused, right? So it is in series. So let's take this name is A, B, C, and D. So R equivalent between what? A, B is 6. And 6 ohm and 3 ohm is in parallel, right? So 1 by 6 plus 1 by 3 parallel. So 1 by R equivalent. Now what? Then you'll solve it. You'll get anyway. So it is going, let's solve it. 6. So it is going to be 1 plus what? 2. It is going to be what? 3 by 6. So 1 by 2. So R equivalent, it is 1 by 2. And R equivalent is 1 by R. So R equivalent is going to be what? 1 by 2 only. Another way, what we can say here, that multiplication, whenever two resistors are in parallel, then you apply what? Multiplication by addition to get. See, 6 3s are 18, right? 6 3s are 18. So 18 by addition, 9 plus 2, 6 plus 3, so 9. So 18 by 9 is what? 2. By that way also you can do. So whenever two resistors are in parallel, M by A, multiplication by addition. Current through the battery. We know V is equal to what? IR. So what is V here? 10. I, we don't know. R is how much? 2. So I is 2 ampere. Okay. Now what happens here? That current will come 2 ampere till here. But we want to find current at 4 ohm. So of course here it will change. I1, right? And here will be, let's consider I2, right? I1 and what? I2. Understood? So if you'll find I1, now it is not going to be the same. So one thing we know, that voltage is going to be what? Remain the same. So here is 10 volt. So we can say here will also be 10 volt. Here will also be 10 volt. Yes, of course, that is going to be the voltage here and here. Why? Because in parallel voltage is same. So in AB, if you will see, if you want to find current in AB, current in what? AB, I in AB is equal to V by R, 10 by 6 ampere. So that is the current in what? AB. Now voltage on 4, of course the same current is going to flow because it is in series. So here also 10 by 6. So voltage at what? 4 ohm is going to be what? 10 by 6, right? Now current at AB like 4 ohm is what? 10 by 6. Now voltage is equal to IR. I is how much, guys? I is 10 by 6. R is how much? 4 ohm. So 40 by 6 volt is the voltage at what? At what? 4 volt. Hope so you guys got it. Understood, everyone? Let's see the next question. Next question is what? Four, 2, 4, everything same. 2, 4, 2 ohm and 4 ohm. And then what here is 3 ohm. And then here is also 3 ohm. Here is 10 volt. Yes. Here is 2 ohm, 4 ohm, and here is what? 2 ohm. So the first question they are asking here, find R equivalent. First question. Second is what? Voltage and current. Current I and V at 4 ohm. Try this question. Try it once by yourself, then I'll try. Pause it and try it. So let's see now. Find R equivalent. Second is what? I and V at 4 ohm. So solution, if you will see, so we can say now, find R equivalent. So obviously these two are in series, right? So let's name them A, B, C, D, right? So resistance in between what? AB is going to be what? 4 to 6 ohm, because in series. Then I told you what? Between CD is 3. So AB and CD, if you will see, find the R equivalent. Multiplication by addition, ma, right? Why ma? Because two resistors are in what? Parallel. So we can say what? 6 into 3 divided by 6 plus 3. So 9. So 2 ampere, right? Now 3, once you solve this whole circuit, then what? This is in series with that, right? So we can say now 3 ohm is in series. So R equivalent is 2 plus 3. That is going to be what? 5 ohm, right? 5. Understood? 5 ohm. So current, let's find current through the battery. Current I through battery is what? I is equal to V by R. V is how much, guys? 10 by 5. So current is going to be 2 ampere. Current is going to be what? 2 ampere. Current through the battery. Here we did correct only, no? How I had 2 by 5, right? 2. So here it should be what? 5 ampere, no? Fine. So 2 ampere. So that type of calculation mistake can happen, right? That is not calculation mistake, it's a printing mistake. Fine. So we can say 10 by 5 is equal to what? 2 ampere. We got current through the battery. Now the same current is going to come till here. We can say there will be a voltage drop, right? The current will go with full energy from here, from the negative terminal start till positive terminal, then it will go like this, right? It will go too fast. Then what will happen? Slowly it will come to what? Again to the negative terminal. Again it will take energy. Again it will go like this, right? So here it means what? In these resistors, it is losing energy. It is losing what? Energy. Going like a king, coming like a right or down. Fine. That is what happens, right? So we can say now voltage is equal to what? IR. So voltage drop we are finding at 3 ohm. So we can say IR. I is how much, guys? 2. R is how much there? 3. So that is going to be 6 volt. Oh, 6 volt is already used here. 6 volt is what? Already used in 3 ohm. 6 volt is already used in 3 ohm. So how much will go remaining? 4 volt here, 4 volt here. Then the same question now. So 4 volt if here, now we can say voltage across AB is how much now? Voltage across AB is 4 volt. Voltage across CD is how much? 4 volt. Now we want to find current and voltage at 4 ohm. So current current at AB is what? I is equal to V by R. Voltage is 4. Resistance is how much, guys? Total resistance. Not only 4 you'll have to take. So it becomes what? 4 by 6, 2 by 3 ampere. So current here is 2 by 3. Here is also 2 by 3. Got it? Now we can say that voltage is how much at 4 ohm, because some voltage will be used here also. V is equal to IR. I is how much? 2 by 3 into R. R is how much there? 4. So we can say 8 by 3 volt. That will be the voltage and current in this resistor. Hope so you guys got it, how to find current, resistor, right? Current and all in this circuit, right? Let's see another question. Suppose let's do little series parallel. Let's play with more series parallel sums, right? Chalo. Now we can say, let's start from the point A. No, my pen is, this is my pen. So sometimes it creates little problem. Yes. Then what? Here. Again, the same thing. What I'll do now, it will be easy for me to draw by this way. Yes. Then this. Then this. Same thing here. Then this. Then this. Then this. This. And then what? And then again this. Fine. Now what I'm going to do in an easy manner, I can do by this way. The color is going to be the same, similar kind of. So let me take this color. A, and this is B. All resistance are 3 ohm. All resistance are of 3 ohm. So they're asking find resistance between A and B. Find resistance between what? A and B. So what we will do here, how we'll solve? Let's see. These two are in what series? So it becomes what? 6. 6 and 3, these two will become what? Parallel. So it becomes how much now? So this 6 and 3, what? 2, right? 6 and 3, 2, 2, right? No. It's already, this becomes 6, 6 and 3, 18, 18, then 3 and 2 and 3, 5. 5 and 3 in what? Parallel. 15, 15, 5, 15 by, again, let's see. 6, right? 6 is there, 6 and 3 parallel. Whenever two resistors are in parallel, then multiplication by addition. So it is going to be how much now? 2, right? So it means till here it becomes 2. 2 and 3 parallel, 2 and 3 series. So becomes what? 5. That 5 is what? Parallel with this 3. So 5 3s are 15. Multiplication by addition. So 15, 15 by 8. 15 by what? 15 by 5, 2 and 3, 5, 15 by 8. So till here you got how much? 15 by 8. Let's see the same way. We can do now. What is that? 5, 6, 6 and 3, 2, 2 and 3, 2 and 3 what? Again 2 and 3 series. So 5, 5, right? So we can say now it is like this. Leave it. Till here, how much we are getting? Till here 2, 2 and 3, 5, right? So A, yes, that's it now. Now till here what we got? 2, 2 and 3, 5, right? Same thing. 2 and 3, 5. Yes, and this is also what? 3. So 1 by 5 plus 1 by 3 plus 1 by what is that? 1 by 5. So the LCM is going to be how much? 15, 1 plus what? 15, 1, 5 plus what? 1. That is 1 by R. So 7 by 15. Is it wrong? Anything left here? I was getting, but correct answer is something else. So it is 7, correct? Correct only, no? 5 and 2, 7. That is correct. Here it is what? 6, 6 and 3, 2. Correct only. 3 and 2, 3 and 3 and it is 6 and 3. 18, 6, 2, 3, 3, 6, 6 by 3. So 6, 18, 18 by 9. So 2 only, correct. So 2, 2 and 3. Anything will left here? Answer is something else. Okay, we'll solve later, no problem. So that is what the answer is coming. Now let's see another type of question. Let's consider find what current in different suppose current is given and you are supposed to distribute in parallel. So it's kind of a trick to find what current. Trick to find current. So let's take this is 1, this is 2 ohm, this is 3 ohm, this is I1, this is I2, this is I3. This current is given as 5 ampere. Now they are asking find current I1, I2, I3. Find current what? I1, I2, I3. So find current what? I1, I2, I3. Find the ratio of I1. Find current I1, I2, I3. So this method is known as what? Componento dividend. Then, right? So I1, if you want to find, then what we can do here, how find, write it like this. 1 is to 1, 1 is to 2, 1 is to 3. 1 is to 1, 1 is to 2, 1 is to what? 3. So we can say now, find the ratio of this. This becomes what? 3 is to, what is that? 3 is to 2, sorry, 6 is to 3 is to what? 2, right? 6 is to 3 is to 2. How? Take LCM 6, 6, then we can find the ratio. Fine. So if you want to see here, the current I1, so add all first. 6 and 3, 9, 9 and 2 is what? 11. 6, 3, 9, 9 and 2, 11. So first I1, if you want to find out, then write 6 by 11 into 5. That is the current. See how easy way. I2 again, not 6, 3 by 11 into what? 5. I3 is how much? How we will find? 2 by 11 into what? 2. 5. So by this way, you can find current in parallel circuit. Current in what? Parallel circuit. Hope so you guys understood how to find what? Current in parallel circuits. Let's see few more questions on series and parallel. Suppose if this types of question they will do. All the resistance are R. All the resistance are R. All the resistance are R. They are asking find the equivalent resistance between, find R equivalent between A and B. A and what? B. So we can say this two are what? Series. So 2R and R is in what? Parallel. So multiplication by 2R into R divided by what? 2R plus what? R. So multiplication by addition, right? Ma. So 2R square divided by what? 3R. So we can say what? 2R by 3. 2R by 3, R is what? Series. After that, if you will see, it will be like this. So this becomes what? 2R by 3R, and this is what? R. This is what? R. This is A, B. So we can say 2R by 3 plus what? R plus what? R. So that is going to be what? 3R, 3R, 6R. So 2R plus 6R divided by what? 3. So it is going to be 8R by 3. That is the R equivalent. Hope so you guys got it. So by this way, we can find what? Current. Now let's see another question here. Okay, one type of question is this, right? Now let's see another question we want to find here is what? Potential method to solve the circuits. What is that? We can say potential method. Let's see this types of question. Suppose this is A and this is B. Find R equivalent between A and B. Find what? R equivalent between A and B. So what we will do here, so easy question. Let's take this point is A. So in between there is no resistance. If there is no resistance, then the energy will not be lost. Sorry, if there is no resistance, then voltage is going to remain the same. So this will also be what? A. If this point is B, so this will also be what? B, right? So we can say, if you see here, then all the resistance are in what? AB, BA, AB, right? This is also B, no? Right? So we can say now this resistance AB, this resistance again what? AB, AB. So R by 3. This way you can find. Understood? Let's see another question now. You take this question. Suppose this is A and this is what? B. They're asking find equivalent resistance between A and B. Find what? Equivalent resistance between A and B. Try it once. Find equivalent resistance between A and B. Find equivalent resistance between A and B. So we can say if this is B, so this will also be what? B. This will also be what? B. This will also be what? B. Right? Why? Because in between there is no loss of potential, right? So we can say all the resistors are in between what? AB. Right? All the resistance are in between what? AB. This resistor, AB. This resistor, AB. This resistor, AB. This resistor, AB. So all are in what? Parallel. So we can say R by 4. Got it? Now let's see another question. What I did here, that in between there is no resistor, so no potential drop. A, B. So Find equivalent resistance between A and B. All are R. So again, what? This is what you try. See, whenever I'm giving question, then you should pause it and then try to solve it. So let's see. We can say now what? B, B, and B, right? So all the registers are. Now here is what? One more point you'll have to take here. Let's consider this point is what? X. You cannot take this is A, because in between there is a register, right? So all the registers between A, B, and X. Okay, so BX, right? BX, BX, and then what? AX. So like this. So R by 3 and R is in what? Series. So this will give you what? R by 3 plus what? R, 4R by 3. That is the answer between what? A and B. Hope so you guys got it. Understood, no? Everyone. Now let's see next question. So this point is A and this point is what? B. This point is A and this point is what? B. All the registers are R. All the registers are what? R. Again, simple. This is pretty much simple. Now see, this is A. So because in between there is no drop. So this is also what? B. Now all the registers are in between what? A and B. A, B. So 2R. All right. Again what? It is 2R. Again what? 2R. Again what? 2R. Right? So all 2Rs in what? Parallel. Find the answer till here. Okay. Till here we'll solve this combination of resistance. We'll see in the next class. Till here you guys revise. We'll see in the next class.